Well, anyway, thanks for inviting me. I know most of your universities, like Munich and Eindhoven and so on. I've even been there to most of them, etc. I don't think I know the specific persons from Eindhoven or from Munich. DTU, of course, we know. We have been in I don't know how many projects together, maybe 5 or 6 or 7 EU projects together. So we are very familiar with the academic world. Basically, we are trying to change the biggest industry in the world. That's a major undertaking, and we are trying to do it globally. So you almost cannot do anything bigger. So my thought has always been, we need as much help as we can get. So whatever you guys can bring to us and help us with is great for us, which is why we have always fertilized these academic relations and cooperated with the academia in many different countries. We also actually sell our printers to a lot of universities. I think by now we have them at 7 or 8 universities or so, both here in Europe, in the Middle East, and in the US. Anyway, so what we are doing, because we are trying to change this construction industry globally, we have to do massive innovation efforts, because we are trying to disrupt this industry on the basis of 3D construction printing. And yes, it's true, as Aaron said, that I was a hired gun. I was the CEO for the first 15 or 17 years of my career, ended up being a group CEO of a company with 1,000 employees. I'm mentioning that just to make you understand I'm not green behind the ears, right? And you can also just look at me and I'm not. But that's very different from other tech startups, right? So, summary about Cobot. So what is very important to understand is that we don't do construction projects. We do technology, and we sell technology. We are a Caterpillar kind of company. We've now sold 85 printers worldwide. That is more than all other suppliers, even when you combine their sales. So most of the others have sold 2, 3, 4, and this compares to our 85, right? So for instance, in 22, we made a count of all the 3D printed buildings that was made that year. 56% of them was made with our technology. So we are clearly dominating. We have also printed the biggest, the tallest, the fastest building, and so on. And we have actually an unbelievable track record, also because from a finance point of view, and that's important to me, we became profitable already after 1 year. So we had 1 year of losses, and then we started making money. That's very unusual for a tech startup. So we 9-doubled sales to above 100 million Danish crowns, 16 million euros. And on the way, we actually picked up some really world-class shareholders, because we picked up first Perry. And for those of you that don't know Perry is a manual competitor to what we do. We give shape to concrete on site. In essence, that's what we do. If you don't give it shape with 3D printing, you give it shape with formwork equipment. And that's what Perry is the leading provider of worldwide. So that was, of course, a great quality stamp on us, that the biggest manual competitor came and said, hey, these guys we can't beat, we better join them. So that was really nice. Cemex, 5th largest cement and concrete maker in the world. Holcim, the largest in the world. And then General Electric. So quite powerful minority shareholders. Danish side still control, equal I control. So as said, head office in Denmark, offices in Florida and Kuala Lumpur. Every time you see a flag, and it's not all flags that are there, it represents where do we have printers. And you can see we are spread all over. We are on all livable continents of the world. So that's what we do. We develop, we manufacture, and we sell what I call multifunctional construction robots based on 3D printing. That will make sense to you later on in the presentation. Besides from our shareholders, we also have some fantastic customers. Any of you know this company? Danish origin, actually, founded by 2 Danish guys back in 1937. 130,000 employees, biggest construction company in India, biggest construction company in Asia, huge company. Orascom, biggest construction company in Egypt, 50,000 employees, and so on and so forth, right? So we have a lot of high-power customers. And also quite fascinating, we are probably around 100 people. They come from 35 different countries. Because from the beginning, we have said, We want to have the best talent, and we don't care where they're coming from. So it's a whole mess. You know, we have Muslims and Hindus, and they're all over the place. We actually have more international than where we have Danish, and a lot of them are coming from DTU. Yeah. So why were we created? We were created to cope with this huge problem of construction, which is the lack of productivity. So all other industries have been industrialized and therefore increased their productivity. Therefore, relatively speaking, their products have become cheaper and cheaper, right? Think about a car. If you buy a car for 30,000 euro now, the same car 20 years ago in a much worse quality also costs 30,000, right? Because the productivity gains ate the increases in material cost and labor cost, etc. That didn't happen for construction. That's why we see a housing crisis almost everywhere. We are getting richer and richer as countries, but fewer and fewer people can afford to having their own house. This is the reason, lack of productivity. Hence, there's a huge need for automating and industrializing the construction industry. The other reason is, of course, nobody wants to do this work anymore. Ask young people to do physical construction work. No, thank you. Give them a laptop and play around? Yes, please. And this is a huge problem, especially if you look at a country like Japan. For every 5 people that retire in the construction industry, they can hire one for every 5. They run out of people simply to build. So we need to automate in order to continue building the same way, the same amount, sorry. And then, of course, as you also pointed out, Aaron, it's very unsustainable what we do. And a big part of that, why it's unsustainable, yes, we use concrete, and concrete, of course, with CO2 is not good, but it can be made better. And the cement factories are really working on it. They're actually working on becoming zero net in 2050. They will have changed the way they produce and so on, so they have a zero net from cement. The other reason is that we simply use too much material because of lack of limited design possibilities. When you work and things have to be straight all the time and have to be 90-degree corners and so on, you end up spending way too much material. And I'll give some examples of that. Also, the other consequence of that limited design possibilities is, of course, you create these boring designs and then you repeat them because creating new ones is just simply too expensive. So you end up like, this is a US suburb, you're being put off here, you live there, but you can't tell the difference, right? Because they all look the same. So this we can help with because we can automate, which means lower labor cost and less need for this scarce skilled workforce, more precision, quality, and safety. Speed, we can execute much, much faster. This is an example from Kenya. Try building something in Kenya. 1 house, 1 year. Here we did 10 houses, 10 weeks. We didn't do the entire house, we did the walls, right? Or our customer did. Sustainability. This is what I spoke about before. This is a traditional made caisson underwater foundation. This is an optimized design because we can optimize the design. We can give it the geometry that gives the maximum support to the structural engineering solution. 53% less material. 53. So for years we have built like that because that's the only thing we could figure out with the conventional solutions. But we couldn't do it like that and spend half the amount of material. Mind-blowing, huh? And then, of course, this architectural freedom. Here you see an example of that. That's a twisted data center. This is located next to a kindergarten. So it was a requirement that it looked not industrial and boring, but looked inspiring. So Perry gave it this design. Anyway, so our mission is to enable the construction industry to build smarter using multifunctional construction robots based on 3D printing. We want to do visually appealing things with high quality, both buildings and concrete structure, faster, cheaper, and more sustainable using our technology. And the vision is, at a certain point, we can automate 50% of all processes on a construction site. Not 100%, that's too much. That's probably never going to happen. But at least 50% of them. And we will do that by developing 3D printers into becoming multifunctional construction robots. Here's an example of one of the buildings that has been printed by us, by our technology. It's from Riyadh, Saudi Arabia, 3 floors, 345 square meter villa. Very interesting design feature they made. They plastered here. Here they kept the 3D printed. That gives an interesting effect. We can also see a little from inside. So they also kept some of the walls inside as 3D printed, and some of them they plastered. You'll see that in a second. Well, whatever, we'll skip. This is the largest 3D printed building in the world presently. Unfortunately, we have not been able to do PR about it because it's a bloody Indian army. so it's difficult. But it's quite nice, huh? Actually, the whole site has 4,000 square meters of 3D printed building. So forget this thing about we are printing 50 square meter or 100 square meter houses. This industry is becoming bigger and bigger and taking over more and more construction jobs that are bigger and bigger. This is an example from Ireland. It's a row house, right? 1 unit, 1 unit, 1 unit, 110 square meters each. Built 35% faster than if you build it conventional. Built according to the new ISO standard. Right? Really nice.
Is that rounded corners or does it just look like that?
They're always a little bit rounded because we can't do 100% or 90%, sorry. This is a video of how it was done. Is it playing? Maybe I have to do, yeah. Mm-hmm. So where we are distinguishing ourselves from the competitors is scale, right? We do big things. Yeah. This is examples of how fast you can build. This is from Oman. They did 3 different buildings, respectively a toilet, cafe, and a fisherman's house in 3 different locations. So first they set up the printer here, then over here. So they moved the printer, 3 buildings, 8 days. That's 2 to 3 days per building, right? And because we're in the Middle East and it's bloody 48 degrees during the day, they print at night.
That's so impressive.
Yeah, and the next one is
drink some water, because it's very hot.
Yeah. Even at this time, it's 40 degrees or something, right?
Yeah.
This is a small toilet. It's almost printed in just one evening. Anyway, you get the idea. Okay, so focusing now on the innovation efforts, we spend a really large share of our resources, our people, our cost, on R&D, on innovation. It's 35 to 40%. So it's a massive amount. I think it's even more than Novo Nordisk. And we still manage to make money, so this is not bad, huh? Yeah, at least until further. So we do make innovations within multiple areas or sciences. So we do, of course, printer, hardware, and software. That's what you normally think about that we would do. We would develop our technology and the related software. But that's not it. We also do, that's actually where we do the most in terms of application areas. So we are the first to think about how our technology can be used for new application areas. Because the thing is, the customers, they will not buy our technology for an application unless we have proven that it can be done, right? So we have to go in the front and do it. Then, of course, we do these design and structured engineering solutions. You saw that before with the caissons, and we also do it on materials. So we have a lot on our plate, which is, again, why we need all the help we can get. So you've seen a lot with this printer. This is Bot 2, the best-selling printer in the world. Of the 85, probably 70 of those are Bot 2s. But we have then later on developed 3 new printers: the XL, extra large for size, Bot 3 for multiple houses, and Bot 3 Infinity for warehouses. I'm not going to show the last one, but I'm showing the 2 middle ones just to give you an idea. This is the biggest print job in the world. These are the biggest printers in the world. Notice what we speak about here: 100 meters in length. 2 printers, 50 meter lengths each of them, 30 meters across, and 15 meters in the height. So yes, do we think we can print apartment buildings of 5 stories or whatever? The XL comes up to 25 meters, in this case it's only 15. Do we think we can do that? Yes. Do we think the way that it's been made so far is not optimal? Yes. Why? Because we're using panels, elements that comes from a element factory. They have to put reinforcement in, no matter whether it's needed in the final building or not. Because otherwise they can't lift it out of their mold, they can't transport it, and they can't crane it in. So think about that. I think a lot of the solutions we're doing today with precast elements, they are wasting material. Simply because their production method in the factory requires that you have the reinforcement, not at the final building site. I had an example with a German garage manufacturer, and he said he made it as precast, the whole thing, the whole garage. And then I said, what is the competitive solution? Well, that was bricks. I said, are the bricks reinforced? No, they were not reinforced. And then I heard about how much reinforcement he put in. And actually, we analyzed his cost, and his highest cost of concrete, reinforcement, labor, transport, installation. What was his highest cost? Reinforcement. So I asked him, of this reinforcement that you're putting in, how much are you putting in for the benefit of the customer? And he looked strange at me and said, but Henrik, everything. I said, are you sure about that? Yeah. All the reinforcement was put in for the sake of the customer. I said, I don't get it. You just told me bricks were the competitive solution. You also said bricks has no reinforcement. And I think we agree that bricks are not as strong as concrete. Yeah, of course. Well, then you'd put in all the reinforcement for you to be able to precast it. Not because the final building needed it. Because I can build with the softer material without reinforcement. Right? Mind-blowing, huh? This is the Bot 3. And just a visualization of how it's meant to be used, right? One house after another. And then we have developed these wheels so that you can actually take several of the modules and then move them very fast. So the idea is you start up here, and when you come here, when you're finished here, you take these and you move here. So constantly, so there's no length limitations. I forgot to say that all our printers are modular. So every time you see a logo, it's 2.5 meters. And the modules can be interchanged between the printers, of course, so we don't have to produce so much. Okay, so now turning to how do we then make these multifunctional construction robots? Well, we do that by actually adding other tools to the printer. So here we see the print head as normal, but over here we see an extension arm running in between 2 x-axes, and at the end of the extension arm there's another robotic arm holding a shotcrete gun. So now we can shotcrete and 3D print at the same time. Multifunctional construction, right? But it could also be like this. Extension arm, robotic arm, and then maybe a plastering, painting, or insulation. By adding the robotic arm, we get a lot of functionality. We can do all kinds of things with the printer then. So it's no longer a printer, it's a multifunctional construction robot. We develop all this technology, but it's also a question of getting better to use it. So here you see an example. This is from the first time we did the Eurostars 3D printed building. We fucked up a lot, sorry my language. It took 2 months. Then Perry came and made the investment in us. And I then said to my guys, listen, we need to do something to impress them. Because, you know, Perry's management was coming to visit us, 8 guys for a whole day. So I said, we need to do something so that they really can see that we spent their money wise. And in the meantime, we had done the Bot 2 printer that you see there. So I thought, we're going to print the same building again, not on a site, but within a warehouse, so we can prove how fast we are. So we were sitting in the meeting room, and I asked him, you know, the management there, Perry, I said, you know, I've thought about maybe printing the Bot building, that's what it's called, one more time. How fast do you think we could do it? And, you know, one guy said, maybe half the time, so 4 weeks. And the other guy said 3 weeks. And then the most optimistic said 2.5 weeks. I didn't say anything. We drove over. This is in the tunnel factory. I don't know if any of you have been there. It's a very, very big warehouse. And we drove in. And when we came in, the building was standing there. And they were looking at me and said, you're crazy, Henrik. You actually did it. I said, yes. And how long time did it take? 28 hours. Came from 2 months to 28 hours. And typical Copa style, we document everything. They were impressed.
With the clock.
Yes. Yeah.
That's a very important.
Yeah. And actually, the first 2 days we printed half of it, and the last day we printed the other half. So we learned as we went, right? Yeah. So there's so much learning to do, right? Even for us as the developer of the technology, in order to master the use of it. Oh, now I went too far. So the other innovation, of course, we're doing is within application areas, as I said. So we came up with the idea of 3D printing windmill towers. So when General Electric called us and they wanted to discuss, they said, you printed this building in Copenhagen. Yes. I said, yes, but that's probably not what you want to discuss with us. And said, no, but it was a secret. But we had to sign an NDA. And I said, but it's a no-brainer. You want to print windmill towers? No, they didn't say that. I said, no, I know, I said it. But anyway, 2 months of discussion with a bloody NDA, and what did they want to do? 3D print windmill towers. Why? Because windmill towers are conical, right? So they go like this. They have a wider base than they have at the top. You need 4.5 meters up here, and then if you go down, you need 2.5 meters up here, and if you go down 80 meters in conical, you end up at 4.5 meters with 80 meter height. 4.5 meters is the maximum you can transport. Otherwise, you run into that. Do they want to go taller than 80 meter? Yes. Is that possible with 3D printing? Yes. We have a factory on wheels. We just bring the factory to the installation sites. No transport limitation. We can do it as much as we like. So that's why General Electric became a shareholder. This is from, and again, this is an example. They didn't just buy a printer. They said, first, you prove that you can print a tower of 10 meter, and then we will consider buying a printer. And this is from the first print, and you can see there's a lot of people running around. It's actually not my guys. It's General Electric and Holcim. Yeah. So it took 3 weeks, and they were super happy from General Electric. And I was like, yeah. And they asked me, Henrik, why are you so grumpy? You're normally a happy guy. I said, well, I don't think it was good. I mean, I think we spent way too much time. And then they said, what do you think the next time? How fast could you do it? I said, maybe not the next time, but after 5 times, we could do it in 3 days. The year after, we did it, a bigger one, and we used 3 days. So from 3 weeks to 3 days because of experience, right? Because of getting, yeah, here you really see the magic, right? This guy, he's texting his wife because he's so bored, right? And he's the only one working. Anyway, here you have the caissons. As I spoke about, it's quite obvious when you are an engineer, right, that if you have water pressing in, it's fucking stupid to make a straight wall, right? Because that's the weakest you can do. Why don't we bend it out? And then they went, it was Asiona from Spain, they said, yeah, but we can't do that. No, I said, but that we can do, so that's not a problem. So we designed it like that. Our head of innovation is extremely fast. He does a drawing like that in like 3 minutes while we speak. And then we said, so what do you think about this? This is like a first trial. And they said, wow, we've never seen anything like it. And we thought, well, can it work? Maybe, so let's do a workshop. So there was a 2 days structural engineering workshop, and they ended up with that design, 53% reduction. 53! We're wasting materials because of stupid structural engineering solutions, because of limitations in the way we have manufactured things. Yeah, but that's how it is. And now I'll come with an even more stupid example. Okay, this is a tank, right? The pressure, of course, you know that, is a consequence of the height of the water that is above, right? So down here, we have a lot of pressure. In the middle, not so much. And on the top, almost nothing, right? So how do we do it in the real world when we cast these in situ? We get clever structural engineers, probably educated from DTU, saying, here, we need 40 centimeter. And then we do 40 centimeter all the way up, because that's the only thing we can do with our solution. And I'm like, that's so bloody stupid, because we don't need 40 centimeter up there, right? So first, simple solution, we just print with a 40 centimeter nozzle, then a 30 centimeter nozzle, and then a 20 centimeter nozzle. Then, of course, long-term the vision is to print with a variable width nozzle like that to really optimize it further. But think about it. All tanks that have ever been constructed have spent 25 to 30% too much material. Stupid. Finally, we print with concrete. That's very different from all the other guys. They run around with their small robotic arm printers that cannot print anything, and they use a mortar that's way too expensive and not known in the building code. We print with real concrete. That's an innovation we've done with CEMEX. We have two sets of additives, so we use completely normal cement, sand and gravel, completely normal, water, everything sourced locally, not linked to any brand. This was a requirement from our side. It could not be a CEMEX solution where only CEMEX cement would work. It had to work all over the world, no matter the brand of the cement. Two sets of additives. One set we put in here, a plasticizer, making the concrete very flowable because it has to go in the hoses. When it comes up here, we don't want it flowable and goes out. We want that it's stiff and it forms stable. So up there, we add a stiffener, another set. So we did the, let's say, hardware technology, and CEMEX developed the additives. So now we can make concrete all over the world based on local available materials. That's a big part of why we have become so leading in the industry. And that's it. Thanks a lot. This one, look at this. I still believe.
To learn more, visit am2pm-project.eu and follow for updates.